Episode 170 of CppCast with guest Damien Bull, recorded October 10th, 2018. This episode of CppCast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/CppCast. In this episode, we discuss std.any and PyTorch. Then we talk to Damien Bull. Damien talks to us about the current state of WebAssembly and nxxm. Welcome to episode 170 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing all right. Rob, how are you doing?
I'm doing okay. Not too much to report. A week or two after CppCon now, so
yeah,
back in the
fully
flow
recovered.
of things. I'm recovered. You?
Yeah, I think so. I kind of lost my voice almost, which is a little weird for me, but I don't know, some allergies or cold or something. But, it's a conference with 1,000 people there.
Yeah.
Probability of picking up a cold is not low.
Okay, well, top of episode, I'd like to read a piece of feedback. This week, I got a tweet from Kuba Sejdak, who I guess was probably at CppCon. And he wrote, CppCast will never be the same after seeing Rob Irving in full size. And I got a couple comments like this when at the conference that people were just not expecting me to be as tall as I am. Actually, I had one person say that I don't sound tall on the podcast, which I didn't quite understand. I don't know how you sound tall or not tall.
Well, I know you always build a mental picture of somehow. Like I've seen this with like radio hosts, right? You're like,
yeah.
I have some idea what this person looks like, and then when you actually see them on a billboard or something, you're like, that is not the right person.
But
how tall are you?
I'm 6'5", and you can, in the picture I posted for last week's episode, you can kind of clearly see the height difference between you and I, with us next to Phil Nash and Anastasia and Timur.
Yeah, you're nearly a foot taller than I am, really.
Yeah.
I'm looking this up in centimeters just so that our 6'5" 195 centimeters.
2 meters? Oh, just under 2 meters.
Yeah.
Okay. Yeah. Well, I'm sorry that CppCast will not be the same for you, Kuba. I hope you continue listening to the show. We'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Damien Buhl. Damien was a Qt on Android contributor, which he presented at DroidCon 2011 in Berlin. He maintains Adapt Struct and Boost Fusion. For a long time, Damien worked for a 100-year-old IoT company and now works on nxxm. He has a passion for C++ and JavaScript. Damien, welcome to the show.
Hi, welcome. I'm really thankful to have you to have me on the show. It's my first time doing a podcast, so thank you for bearing with my French accent. I like your introduction that you made of me. That's really great. Thank you very much.
All right, I have a question that's not directly related to your bio, but I did notice that you're from the southeast corner of France, where it looks like the town that you're in actually has a German name, but you're in France, and you're like right there where Germany, France, and Switzerland all kind of meet, right?
Yes, that's the Dreiländereck. We say it in our language. It's like the three border region. We have Germany, Switzerland, and France at the same place. And most of the people here just live in France and go work in Switzerland and buy their things in Germany because it's cheaper to buy in Germany, better paid in Switzerland, and better to live in France. But I like the three countries.
That sounds like you're cheating.
I think the other citizens of France might think that as well, but no, it's really fair, and I think every country is profiting from the situation, you know.
My brother lives in northwestern Switzerland, and I've experienced just how much cheaper things are in Germany than in that corner of Switzerland. Like it's crazy how much cheaper things can be.
Yeah, the difference is high. That's true. But I think a lot of Swiss people go make their shopping as well in Germany. Yeah.
So I'm sorry. Go ahead.
I am half Swiss and half French. My mother is Swiss, my father is French, so I have both citizenships. So yeah, that's a nice place to live for me. I live on the border, really. So that's good.
Do you then, since you do sometimes like shop in Germany and stuff, do you speak German also? Do you do most of your business in French and in English?
And I speak German also, and I speak Swiss German also, which is a quite different dialect, so to say. And at work, most of the time we speak English, but there is during the coffee pause and so there is German as well. Yes,
wow.
Swiss German. Yeah,
sounds like an interesting place to live, really.
Yeah,
it's a lot of culture at the same place, and it's really interesting. I like it. But I really love the US, as I discovered in CppCon.
Oh, so you were at CppCon?
Yes. And it was an awesome moment.
And you got to do some travel afterwards, I guess?
I had the chance to rent a big muscle car, like a Dodge Charger V8, and could drive down to San Francisco, stopping in the different places, looking at the redwood trees. I enjoyed Bellevue as well on Seattle. It was really a nice experience. I loved it a lot. Yeah.
Wow, that's that's probably a larger car with more horsepower than you would normally find in France or Switzerland, right?
Yes, right. We have small cars.
Yeah. So it was fun then, I assume.
It was a lot of fun to drive it. I was just like a bit worried about the speed limit, so I couldn't try the engine as I would have liked to. But yeah, that's normal.
Yeah, that's fair.
That sounds awesome, though. Okay, well, Damien, we got a couple news articles to discuss. Feel free to comment on any of these, then we'll talk more about WebAssembly and nxxm. Okay.
Thanks. Yeah.
This first article is an introduction to Torch, or PyTorch, C++'s front end, or the C++ front end for PyTorch. I'm not really too familiar with PyTorch. I guess I've heard about it a couple times online, but they just released their version 1.0, and with the release, they introduced a C++ front end. Before, I guess it was only Python.
Yeah, so this is a machine learning library, as far as I can tell.
Yeah.
Now, I know most of these things are written in C++ for performance reasons.
Mm-hmm. So,
without digging a little bit deeper, my gut reaction is this is a C++ front end to a Python library that's written in C++. Although I'm assuming it's actually the library for the backend, libtorch, is what I understand having gone to the website.
That makes sense, yeah.
But
so if you are comfortable with C++, then you can use this instead of the Python front end that maybe a bunch of scientists are more familiar with.
Yeah. I'm sorry, Damien, were you going to say something?
I think there was a lightning talk about that at CppCon the Thursday evening. And I'm not sure if it's the same author as the article author, but he showed how to use in 5 minutes the PyTorch API. And he was working for Facebook, so far as I can tell. And it was interesting actually to see that now we can finally do machine learning in C++, as you say, with a C++ backend and for a Python library. But the problem with machine learning, I think it's learning all the theory that comes with. I have a lot of difficulties with it. I'm trying to learn. I have a friend who is better at that, but there is a lot of knowledge that you have to get before being able to do any machine learning. It's not just like using an API. It requires a lot of theoretical background that I'm missing for the moment, sadly.
A Humble Bundle just had a machine learning bundle, so I have 14 books on it, and I've read a part of 2 of them, and I still don't know what I'm doing with any of it. So I ended up I started with a fundamentals book, which is all the math theory. I'm like, I don't need to know this. So now I'm just at the how will machine learning change the world book, which is more meant for managers, just to see if I can wrap my mind around it.
Yeah, it's a hard thing to learn, I think. Yeah.
Yeah, and like you said, it looks like there's a lot of background in theory.
I tried once to make for the meeting C++ in Berlin, for 2 years. I tried with a friend to make, there was a t-shirt with all the speakers, famous speakers on it. And I tried to make a program which will take photos of the meeting C++ from Twitter and modify the portraits. And, we tried that hard and we didn't sleep at night, and then we were just, sick and we didn't got any results. So, yes.
That's funny.
Yeah.
Yeah.
Okay, next article we have is about CPP Quiz, which we talked about with Anders Knotten 3 episodes ago, I think. And
something like that.
Yeah, he just made an announcement that there is now an Android app available for CPP Quiz, which I meant to download before the show. Oh, you got yours. Okay.
I got it going, yep.
Nice. How does it work? Is it nice?
Well, I installed it right before we actually did the interview, but just enough to look at it to see that I was honestly not expecting a lot, because a lot of these Android apps for a website,
right?
They're not that special, but it's pretty slick. It's got really good color syntax highlighting and stuff going on, and it tells you the difficulty of the question or whatever and lets you answer it, and apparently synchronizes with the website so you can even use it when you're offline.
Oh, awesome.
I'm downright impressed, honestly.
Yeah. Very cool.
Isn't there any iOS app, also iPhone application for CPP Quiz?
He's only mentioned the Android app, but I'm curious as to how it was Sergey Vasilchenko who implemented the Android app. I'm not sure if he says it's open source, so if someone wants to go and make it for iOS, the code is already on his GitHub, so you can try to do that. Okay,
so it should be something I should try, because I just have an iPhone right now. I don't have Android anymore, so...
It appears that it is all written in Java, so you'd have to rewrite it in a cross-platform language or just write it in Objective-C or something. But, the source is available.
Okay.
Yeah. I'll put the link to that in the show notes, too.
Well, I think also a good takeaway from this is it was kind of a little community collaboration here. So Anders also enhanced the website's API so that it was easier to make the Android app. So theoretically, it'd be easier to make another one in the future for a different platform too.
Right. Okay, and then the last article I have is a post from the Visual C++ blog, and they've been doing these, not really Visual Studio related posts that are kind of just going over newer language features. And in this one, they're talking about std.any and kind of going over the use case of it and comparing it with, what a C developer might do with using void star. And I thought it was a pretty good post, good overview of the feature. And it's not something I think we've really talked about before on the show, right, Jason?
It's maybe been mentioned once or twice, but I don't think we've,
I find interesting std.any and stud variants as well. I mean, I think they mentioned they will make a new article, the next one about variants. But I'm a bit worried that the standard got std.any in the form as boostany was, so to say, because at the time where std.any came in the standard, at the same time there was this new nice feature that's a template variable. And I think nowadays there will be a way better system to make the any type, or to make a variant that don't expect a type list. It will be by using this template member variable for static data member, so that you could actually store in an unordered map the this pointer as a key for the storage of the special type that you want to store in the any, and the value as another template type in the unordered map. And I think nowadays there will be a possibility to make a variant type or any type that you don't need to specify the type list before, but where you can then visit with the type list. And what I don't like so much about any is that Any requires you to make a lot of if is this type, then cast it to this type. And in comparison to variant, where variant you can just pass a visitor to it or a lambda, and the lambda will just be called with the type which is inside it. And I think now that CppCast has this data member template, static data member template variable, I think we could do a variant type which has the simplicity and flexibility of any, but the advantages of using visitors to access the types. I think it's something that we could do. And it might have many applications for interfacing as well with JavaScript and so. So yeah, this was my quote about any, because I find it a bit too flexible, too like a JavaScript variable.
That is true, and I've found only a couple of real use cases for something like that, like in my scripting engine, where you truly can put anything in there and you have no way of knowing, and you have to determine at runtime what's going on. But for the most part, like you're saying, if you have any way of limiting the set of types that are allowed, and it's like a single sentence at the bottom of the article is like, oh, and by the way, if you already know what types can be allowed, used optional or variant. Like,
yeah. Right. There is this grid over any type in Boost. There's this library named type erasure, and they have an any type to which you can add constraints, and they have their own like require syntax of concepts. And so you have an any type that has the function pushback. Then you can store at runtime any type that has a function pushback, and this allows code to run independently or to be written independently of the type that has pushback in the end. And I hope with the new concept coming in the next standard that this library get even better, because then we can perhaps directly use the concept syntax for this Boost type erasure any. I liked it a lot, this library, but it has a small learning curve with an error message as well, naturally.
Well, yeah, I'm sure it does with error messages. I wasn't familiar with that one.
Okay, well, Damien, we first talked about WebAssembly like 3 years ago with JF Bastian, one of our earlier episodes. And I think at that time it was still just a proposal. Can you tell us a little bit about the current state of WebAssembly to get us started?
Oh yeah, I would like to do that. I was at CppCon to give a talk about WebAssembly. So in the first half of my talk, it's not yet online, but when it will be, the first half is about WebAssembly, how it is built in detail and so. But I feel like an imposter in comparison to JF Bastian, who is working on WebAssembly directly and making it happen, as well as people like Kripken at Mozilla. But I'm a user for a long time. I made a lot of customer projects before with ASM.js already. I was always like to my friend, hey, the web, we should build it in C++, but the friend were like telling, no, it's JavaScript and there is nothing else. And no, it's something that happens. WebAssembly is available in a really broad way. I mean, you have all browsers. You have Edge, you have Google Chrome, you have Firefox, you have Safari, and who are capable to run WebAssembly. And all other browsers that are not yet capable, they can run ASM.js. So you can build your application for WebAssembly and have a fallback for the quite old browsers. But WebAssembly in its current state also runs as well on Node.js. And what is really interesting about it is that they have been working hard in making a minimum viable product that everybody can use. So nowadays, we have a standard WebAssembly binary format and WebAssembly instruction set. And the WebAssembly binary format, it's like portable executable or ELF. And at this difference that first it have no legacy, which is great. And on the other end, it also defines the instruction set. So it's totally portable, because a Windows portable executable sadly isn't totally portable because the instructions are either for x86, either for ARM, but you have to have prepared them beforehand. And with the WebAssembly standard that is now implemented in all browsers and available, it's actually possible to load the WebAssembly file in any browser and to have it be compiled for your platform at the moment when it's loaded. And when I mean compile, it's just translated from the WebAssembly instruction set 1-to-1 to the x86 or ARM or whatever platform your WebAssembly runtime runs on instruction set. And what is really interesting is that the CPU instructions that are generated by the WebAssembly runtime are something which is really near to what you can write in the WebAssembly machine model, because you will have like all the optimization you have in your compiler, like O2, O3. You will have the ability to check your WebAssembly instructions, how they look like, and you might make good guesses of how exactly will be transformed into x86 or into ARM. Naturally, you don't have the full control of if it's using a move or a movel or so, but you will be really near to know that what you produce for a binary will be executed exactly in the form that you are used to if you will compile it for the native platform as well. And this is also interesting for performance, I think. It has a really good impact. Regarding what WebAssembly is still perhaps lacking in this current implementation and proposal, but it's moving fast, is that it doesn't support direct access to garbage collected reference objects. And this is important for the web. When you are building a web app, you want to access HTML, and HTML is HTML5 is made on the document object model. Right. This document object model is like a representation of all the HTML node you have. And this, the browser implementers and how the web standard are defined is that they are garbage collected. And so you cannot get an easy handle to this in C++. You have to wrap them in a JavaScript value and to make a mapping with the JavaScript bridge that WebAssembly offers you, that are the possibility, because you have the possibility to import and export function from WebAssembly to the host, and the host is JavaScript currently. But it could be any host as it is specified. And so, this is coming in the next revision of the standard, as well as threads. But threads could be already used if Spectre wouldn't have put his way in. Because if you use tools like mscripten that we ship in nxxm, for example, you can enable the use of thread with because there is a pthread implementation based on workers and on shard array buffer. But because of Spectre, it only works for the moment in Chrome. All other browsers disable that. Hopefully, they will enable it again. So you can, with WebAssembly as it is released now, you can actually compile any of your C++ application as long as you don't do multi-threading, I would say, and as long as you are implementing it in a more asynchronous way and not having a blocking code that is preventing the runtime to run, like for a browser. You know.
Okay, so to make sure I understood, you take your compiler, you compile to WebAssembly, and this is like an abstraction of what an assembly language might be. And then that is directly translated into whatever assembly language or whatever machine code you're actually running on.
Yes, exactly, yeah.
Are there any concerns about, like, I mean, like if I did an array out of bounds access or like access past the end of memory or something, what happens?
Actually, you are jailed in a big array for the WebAssembly host. When they load your WebAssembly module, the WebAssembly module is loaded with a memory, is heap, which is actually a big array, and the WebAssembly host is just not allowing you to write with your malloc or so in any other places than inside this array. So you cannot really make you can crash internally. And then it's your problem and you have to debug it, but you cannot crash the host for this reason. Yeah, the stack is, however, not as you are used to. It is in the WebAssembly engine. The stack is some part of the stack might be because of the C++ implementation might land in the heap, which is this big byte array of that we can access from JavaScript, for example. But mostly it will be managed by the JavaScript engine. So a WebAssembly function will have a stack in the JavaScript engine.
Okay, so now I'm going off, I think, from what anyone would practically want to do, but I'm quite curious. If you are gelled into this giant array, as you said, and you can make JavaScript calls, can my JavaScript code directly poke into that giant array if I wanted to manipulate the direct memory state of my C++ program from JavaScript?
Yes, you can do such kind of thing.
Neat.
And you can share like an image, like a picture, but it will be naturally. It has different, very different techniques. The better one would be to use a shard array buffer that has been disabled by Spectre, but you can generate something in C++ and copy it in one operation to JavaScript. So it's not live access for the moment with a shard array buffer, but there is a little copy. Yeah, but this copy will be optimized by the engine in the end, so it won't be a real copy. Yeah. So cool. For you, it will be the same in terms of performance. Yeah.
That sounds like it could be fun, but not very practical, really, to directly access the memory of your C++ program.
For an image, I think it makes sense for rendering, but you have other option. You can directly access WebGL. You can easily draw in a canvas from WebAssembly. So yeah, it might be easier to do it in different ways. Yeah.
Since you mentioned WebGL, and it kind of sounded like the interface into the DOM is not nearly as good as it could be because we have to jump through these JavaScript wrappers, if I understood correctly.
Yes.
Is the WebGL interface also similarly encumbered, or is it like a nice, clean interface from a C++ perspective?
It is clean. It is not encumbered in the same way because the OpenGL works a bit differently, so that you can ship your OpenGL code to the WebGL engine and it will render what you gave him. So yeah, this is not encumbered in the same way. Yeah.
Okay.
But you will lose like accessibility features, and so if you render everything in OpenGL, naturally, this is because it's for a web page, it's better to render in the DOM for obvious reasons like selecting or organizing for different screen sizes, and so it might be easier to do it with it. Yeah.
Right.
Okay. I'm mostly focused on the DOM story because I think if you have made a video game or if you made an app which is using OpenGL, like if you made, for example, a Qt app and you wanted to render it via OpenGL in the web, there is a lot of work that has been done in this regard, and it works pretty well since a long time. So I think what is nowadays missing for WebAssembly is a good binding to the host. And the people at Mozilla and Google and so on that are working on WebAssembly, they are working on these changes, and this is known as the garbage collection and the reference types proposal. And so this is in the phase of being implemented. So it will be really soon, I think, that we will be able to use it in the major browser, like I think next year, to directly access the DOM without any overhead. But even though there is an overhead nowadays, this overhead is not that at all big, because just today there was a nice article that was posted by the Mozilla people. It is the author is Lynn Clark, and she just wrote an article reporting that calls between JavaScript and WebAssembly are finally fast. So in the last Firefox beta, they have improved the way the calls are done without this new specification, and it happens to even be faster for mathematic API like math random to access it from WebAssembly instead of accessing from JavaScript. So because the engine doesn't have to figure out that accessing from when accessing the API from WebAssembly, that which are the types that are used. In JavaScript, the types can always change and they are boxed. They have to be checked. And she explained that actually the C++ can always be inlined with the call to the built-ins of the browser, so that it never has to check if the types is the right one, and that the calls are finally faster, calling directly from WebAssembly into the browser. So
that's awesome.
I find it nice. And she's saying, or is saying, I don't know if it's he or she, that this will be generalized to other browser soon. So she might have heard something from other browser vendors. I don't know.
Wow.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/CppCast. Well, maybe we should talk a little bit about the some of the announcements you made during your CppCon talk and the work you're doing at nxxm related to WebAssembly.
Oh yeah, that is nice. Actually, we have been working with two colleagues of mine on a project to be able actually to build web apps in C++, actually to access the DOM and so, because as I said, drawing a canvas and making 3D operations is already possible. What we wanted is make it easier to write an HTML app, and for this you need the compiler, you need the libraries that you want to access the DOM, you need the library to pass JSON, and you need to be able to write C++ near to your HTML. And this is what we did at nxxm. It's actually an HTML5 compiler, which is GitHub connected and WebAssembly ready. So the idea is that you can include any repository that is on GitHub that contains C++ code, that it gets downloaded and compiled for your WebAssembly platform, and that then you can just write C++ directly inline inside HTML. So you open an HTML file and you write script type text /C++.
Of course.
And then you just write void main or int main, and you make a cout, so it will be printed to the console thanks to the mscript bindings, or it will be, or you use the Bellevue open source project that I announced at the conference that allows you to access the DOM. So Bellevue is named Bellevue because actually nowadays the web people, they are no more using JavaScript most of the time. They are now saying we use TypeScript or similar frameworks or languages that brings static typing to JavaScript. And I'm like, why would you make a new language for static typing? We have a marvelous language for static typing, which is C++. It is all about having compile time error when you give the wrong type. So why not write websites in C++? And that's what I presented in the talk. The TypeScript people, they use the Seattle skyline. And so I thought we should name our framework Bellevue because the conference is happening in Bellevue. And this is what nxxm is bringing you is setting up your machine, whether you are on Windows, macOS, or Linux, and letting you simply build and write an HTML file, add some C++ to it, link some library, like say I want Boost, like say I want nloman JSON, whatever, and it will just build just from this, because it will read your code to understand how to build it. It doesn't need any special build recipe. This is another main goal of nxxm is reducing the overhead of build files that we have in our project. Because actually, the people in JavaScript, they have a nice tool, it's named npm, and they have a nice language, but doesn't require them to write anything about build. So why C++ people should bother with writing CMakeList if we actually could generate it? Because if you have a main function in some file, then it will be an application. If you don't have a main function, then if it's not used only in an application, then it might be a library. Then if it's a library, you can then use it, upload it to GitHub and use it. And this is what we implemented, is building by convention or building by reading your code to deduce which are the CMakeList file that should have been written. And for users that don't like it, they can still write CMakeList file. They can just put a marker, say, okay, I don't want to use your automatism, and I want to write CMakeList. This is on what we've been working sleeplessly last year. So now we are on the first release. I've been using it before internally for other projects, but now we are going outside, and we are working to improve that.
So if you have a CMakeList file, it'll use that, you said.
By default in the current release, it should use it, but there is a bug that makes it throw, but this will be corrected by next week. And if you don't have if you put ignore CMakeList, then it will just ignore it. In this case,
and it'll just try to guess basically on what kind of project it is.
Yes, exactly.
Are you okay? I'm going to say something bold here. Are you claiming to have solved the packaging problem for C++?
Actually, I think we will never solve it in C++. It's impossible. I think there is a lot of good tries, but when we named nxxm not a C++ package manager, because we think packages are not a natural way to think in C++. I mean, in Java and C# you have the idea of assemblies or of package. In C++, for the moment, we don't have modules. When we will have code that declares to be a module, then we can begin to speak of packages. But most of the time, C++ users, they don't want to pay for what they don't use. So they used to include just what they need. And I think we try to have a different approach is you want just not a package which is per se a thing which has a lot more than what you need. And you just want to include something. And we have a feature that we will ship by the end of this year because it had some bugs, but it looks at the includes that you do in your code, and it looks with the GitHub Search API which repository has this file and which repository is the best ranked, and it selects the best guess that you can override if it's not working, and it just takes this repository because you included it. But you don't have to say, I want the special package, the complete boost. I just want to use Boost Fusion, or I just want to use Boost Fusion include that abstract. And we will look at this, take it, download it, compile it, put it in the sysroot, so that we are in a more finer, granular way to consume other people's code than using packages that someone has to build actually. Right. So that's what we're building.
And also, to clarify, the point is always building WebAssembly files or ASM.js if you need backward compatibility. You're not doing this for native builds, or are you also?
We are, per default, focused on WebAssembly, but we build nxxm with nxxm. So on other tools, and you can just specify over target. When you start the program, you have like we ship like 200 toolchain files, but there are 4 that are guaranteed to work. That is the Windows one, the Linux one, the macOS one, and before all the WebAssembly one, which is the one that we focus on at most. Actually, it is this one is the first citizen in the product. Yeah, but we would like to in the future have like, if you have an HTML file and you are not compiling for WebAssembly but you are compiling for Android, we would like to make a UI in a browser, in an embedded browser inside your app, so that you can directly have a mobile app based on your WebAssembly app that you built. This would allow progressive apps for mobile to be built more easily. Yeah. this is something that we are looking into it. But this is a future point on the roadmap. Yeah.
So what are we talking about from like a performance perspective, compiling our C++ to WebAssembly? I know you said it's directly translated, but like how good is that really?
So there is two things happening in the current browser on the Node.js implementation. Is that first, when it downloads the WebAssembly file, there will be a first compiler, which is really easy. In V8, the engine that is used in Node, it is named Liftoff, okay. Which is the principle is named by Mozilla a two-tier compiler. Is that actually they load your WebAssembly instruction and translate them one-to-one to the CPU instruction of the machine.
Okay.
And then at this moment you have the performance that you would have had if you had compiled for x86.
Okay.
Or if you had compiled for ARM. So you have the same. But then what is even better is that you have in a browser, in this big JavaScript implementation, you have a nice JIT engine, which is really fast. And if they have a CPU core, which is free, which is available, they will then optimize the build again with the knowledge of that the jitter has. So this is something I didn't measure now, but I bet you might have for some algorithm better performances than if you would directly only compile it for the native platform. Because the JIT engine will even optimize more with the runtime knowledge of the value that your compiler didn't know before.
Right.
Because these are things that I saw in Java in the past, is that for some algorithm, Java was faster than C++ because they knew that the input value will never change for a loop. But this is a C++ compiler, if the variable is given at runtime, like via a parameter on the command line, this C++ compiler cannot know it. So he can do his best to optimize it, but he won't be that faster. And there we have the best of two worlds, actually. So I think this is something that has to be measured, and I would like to make a blog post about it when I know it. But I think it's even better than if you would compile it only for the native platform. If we look only at speed, if you look at memory, naturally you will have more memory because you have a WebAssembly runtime there, and you have a compiler or like a translator of WebAssembly to your current instruction set. So this is a trade-off that you have. But if you look at the different JavaScript implementation, there are nowadays not that big. I mean, in most cases you can include them, and there are even small JavaScript implementation for microcontrollers. So I think a WebAssembly implementation for microcontroller shouldn't be as big as well, and should be doable. But this is not yet available.
You know, having started my CS career effectively in like 1996, when it was the height of the beginning of Java, and this was the promise of Java everywhere, and Java on all the embedded devices and little sticks that could run Java bytecode and all of these things, that kind of took off. I mean, sure, our Android devices use Java, but I don't know, it feels like this whole system, this Java ecosystem was designed to be this, and I don't think it ever really did what the original creators wanted it to do. And now we have JavaScript, which is in no way related to Java, that kind of accidentally became the de facto operating system of the internet, and now it's better performance theoretically because we can take advantage of the last 2 decades of optimizing C++ compilers on top of all of this other knowledge. I don't know. It seems like a bizarro land or something at the moment.
Yes, for sure. It's really strange. But I think the WebAssembly runtime are really simple, and they just can take advantage of this optimization. But as I said, the first moment when you load the file in this two-tier compiler, you have a translation one-to-one of your instruction. And they might be changed if it can get faster, but they won't change if it can't get faster. So it's a really static world, so to say. WebAssembly is really static in comparison to Java bytecode. It's a bitcode which is really, it's an instruction set which is meant to be transformed to native instruction set. Java bytecode was not really built for this. They wanted it, but it was not the case in a lot of versions of Java. They made some improvement, but the programming language they are using is not thought to target a native machine.
Right.
C++ is way more thought for it, so it helps actually having the performance natively with the same model, because you have another input. It's not Java, it's C++. Yeah. I think this makes a big difference.
Yeah. I would like to see a Compiler Explorer mode. I know that Compiler Explorer has some support for WebAssembly and for LLVMIR and stuff, but I would like to see the one where I can see, like if I were to compile the same snippet directly to ARM versus compiling it to WebAssembly and what the ARM translation looks like, for example, just to play with this directly and be like, oh, okay, I see what it did there. All right, that's the whole point of Compiler Explorer, right? Is so that we can prove these things to ourselves. I would like to prove it to myself personally, just for educational purposes.
Just in case Matt got both listening.
Yeah, I know Matt listens. So, Matt.
Get on it.
Hopefully it will be cool, but it will require the help from the browser vendor in this case, because it fits for the current browser. But if you tweak a browser, you can do that. Yeah, it's something I did the exercise manually, but it would be good to have it in a Compiler Explorer to be able to check it more often. I did it for small examples. In my slides, I put one example of just returning 43.
Yes.
And it happens to be the same in the end, but it's a simple example, so it would be good to have this in Compiler Explorer, definitely. I would help if someone needs.
Since you've mentioned Node, is there an option for Node to say, please take this WebAssembly file and spit out to me what you translated it to?
Oh, I'm not sure. I don't know yet. I don't know. Yeah.
Okay.
Anyway, I'm sorry, that's off track from your actual project, but it caught my attention, interest there. That would be one way to do it. Then it could be a post-processor and the toolchain for Compiler Explorer. But anyhow.
But the code of the V8 engine used inside Node is pretty well written and is pretty clear. I spent a lot of time reading it at the beginning of the WebAssembly thing and so. And I think it might be easy to export the data out of the code, and if it's not already implemented, it must be easy to do that, because the lift of compiler and the others, it's easy to take the buffer out and bring them to some disassembler, and so it's something we should do actually. Yeah. I've write it down.
One question I had is, it sounds like this is all open sourced work that you had internally. And I'm just wondering, what kind of WebAssembly projects have you actually worked on that are like, shipping web applications, just so I have a sense of what type of things people are doing in WebAssembly these days versus JavaScript?
One thing what was where WebAssembly made sense in comparison to JavaScript, we would say, some people would say, is data logger. So we had a lot of time series. And the problem is that if you send them to JavaScript in a binary format, then the JavaScript code has to transform this binary form in some of its types, and then render them in a canvas to present like billions of time series in a canvas. And this took a while, and the user experience was really bad. So what we did is use a WebAssembly web server and use packed C++ structures of that are trivially copyable. I show in my talk a small snippet of code to do that, and we just memcopy all the samples in this WebAssembly format. I mean in this the C++ binary representation of the structs, because we are using a WebAssembly server on a WebAssembly client which is compiled with the same compiler, but nxxm. Then we just can copy paste all the time series over the wire on a WebSocket connection, and using the WebSocket API from Node and via C++. And then we just throw it in to the browser, and the browser just static cast it to the types that have the same memory layout, because it's compiled with the same compiler, same option. And it just then uses the canvas binding to print them out, and this reduced the load time by 40%. And it improved significantly the speed of the app, and we could even display more data that we could before. And this was for data science problem that the pharma industry has. It was for to look at data and filter them out for to remove all the noise, but all the noise is not always the same in each of their samples. So they cannot have a generic algorithm. They have to look at the data in details easily to then deduce the algorithm, so to say. And but they need, it's a human process. It's for me, it's not possible to do it automatically. There is not enough theory about it. So they needed a tool to look at the scan data easily and in a fast way. So it happened to work really great in this case. And for other things, we did just normal websites like application with C++ because they already had a code base in C++, adding a web front end to it. It was easier to reuse all the domain model and bind it to some to some HTML5. This is this doesn't have so much impact. I mean, it was a great experience to code for the web in this way. There is a lot that we had to do ourselves, because for the moment this binding to the API are not done. But this is what we try to do now, is trying to make this open source. So we are rewriting it in an open source way, because we cannot open source it because it's written for some other people. So they don't want this to be open source. So we rewrite it differently now, but it's happening. And we will be, by the end of the year, I think we will have a really good status where people can indeed use the framework. And we welcome if people would help us and have ideas how to do that better. We're really open and we will assist people.
Where can people go to check out the open source library?
Actually, if you go on nxxm.github.com, if you click on the documentation link, there is the link to the Bellevue open source effort. Yeah, this is that. And it is on GitHub. It is github.com/nxxm/Bellevue.
Okay. Is there anything else you wanted to share before we let you go?
We have a roadmap. We will do a Visual Studio Code integration because for the moment it's a colorful, emoji-full command line client, the nxxm, and we would like to make it a GUI application. So we will integrate it in Visual Studio Code with some buttons and so to make it easier to use and so, and syntax highlighting. Yeah, we are working on this as well for end of the year.
Sounds great. Thank you so much for your time today, Damien.
Thank you for your time too, Jason and Rob. It was a really nice time to have you there and to discuss together. That's really great. Thank you very much.
Yeah. Thank you.
Thank you. Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. Website at cppcast.com. Theme music for this episode was provided by podcastthemes.com.